Students are curious, active learners with individual interests, abilities, and needs. They come to our classrooms with varying knowledge, life experiences, and backgrounds. A key component in successfully developing numeracy and mathematical thinking is making connections to these backgrounds and experiences. A positive attitude has a vital effect on learning. Students develop positive attitudes and self-confidence in doing and learning mathematics in an environment that creates a sense of belonging, supports risks, and provides opportunities for success. The aim of the mathematics program in Alberta is to prepare students to be engaged thinkers who employ mathematical literacy to identify and solve complex problems. The fundamental goals of mathematics education are to prepare students to solve problems, communicate and reason mathematically, make connections between mathematics and its applications, become mathematically literate, appreciate and value mathematics, make informed decisions as contributors to society. These goals are achieved by attending to the three dimensions of mathematical understanding: problem solving, conceptual understanding, and procedural fluency. Keeping these goals in mind, teachers design learning to provide rich mathematical experiences that promote deep conceptual understanding. Learning through problem solving is the focus of mathematics at all grade levels. Students are provided with opportunities to learn by attaching meaning to what they do. They need to construct their own meaning of mathematics. This meaning is best developed when learners encounter mathematical experiences that proceed from simple to complex and from concrete to abstract. This video clip was captured in a grade 5-6 classroom where the lesson was designed to deepen their understanding of fractions.
Fractions are such an important understanding, and they can be really abstract for the students, and unless they have that in-depth conceptual understanding of what a fraction is, what a whole means, what the numerator and the denominator actually are, how they relate to each other. I ate half of my container of ice cream. Whole half.
Really?
What about you?
I think I was hungrier than you.
Really?
I ate 3/4 of my container of ice cream.
Oh my goodness, that's a lot.
It is a lot.
So, hands up, who could tell me who ate more ice cream?
Well, I just thought in my head that, I just thought that two rectangles of the same size, I just split the first one in half since you ate half. And then for the Miss Harvey, I imagined another rectangle, and then I split that one into quarters. And then I thought 1/4 and 1/2, and I compared those two, and then I got Miss Harvey.
So you thought 3/4 would be bigger. I love the way you visualize those images in your head. That's excellent.
Mrs. Cook might eat more ice creams than Mrs. Harvey because that we don't know whose container is bigger.
When the teacher revealed their ice cream containers, they were considerably different in size. The first student successfully explained using reasoning and visualization methods that 3/4 is larger than 1/2. The second student demonstrated flexibility in his thinking by considering the required information that is necessary to answer the question. He recognized that an understanding of what makes a whole was needed. Although students may know their basic facts, in this case, 3/4 is larger than 1/2, they might not be able to justify how they know their answer is correct, and in which situations simply knowing the basic facts is good enough. Teaching for understanding is the primary goal for all mathematics classrooms. In Alberta, all students from kindergarten to high school are enrolled in mathematics. The mathematics program of study offers multiple pathways for students to progress at a pace appropriate for their own learning and future goals. Beginning in grade 8, the mathematics Knowledge and Employability program is offered to students, providing learning opportunities that are practical and applied. In high school, students have a choice of flexible pathways, including the -1, -2, -3, and -4 course sequences. Students are able to navigate between these courses at the high school level. As students come to understand themselves as learners, they are able to determine which course and path suits their learning needs. Students have choices. High school offers programs and pathways that lead toward post-secondary opportunities or directly into the workforce. In order to graduate with a high school diploma, students must successfully complete a 20-level mathematics course in -1, -2, or -3. The minimum requirement for a certificate of high school achievement is successful completion of Math 10-3 or Math 20-4. Some students benefit by taking a course in calculus. Math 31 provides this opportunity, preparing students for higher level courses in mathematics at university, such as those required by Mathematics and Physics Honors Program or by engineering and business programs. The kindergarten to grade 9 program of studies is arranged into 4 strands: number, patterns and relations, shape and space, statistics and probability. The slide shows the dependency of the high school topics on the foundational strands developed from K to 9. For example, the study of trigonometry ties together concepts and skills from shape and space, number, and patterns and relations. While within each topic we strive to move from concrete to abstract, this happens on a larger scale as well as we encounter more abstract ideas in high school that build upon more concrete representations from K to 9. At times, questions arise about how to address the basics in math. Teachers are encouraged to build on previous successes while building conceptual understanding of basic mathematical facts. Current research on math education is guiding teachers to open up mathematics as an exciting opportunity for students to collaborate, create, reason, and problem solve. Math education researcher from Stanford University, Jo Bowler, describes in her new book, Mathematical Mindsets, ways to approach mathematics visually, where students are grounding their conceptual understanding of math. CBE teachers are using research-based resources like this to provide activities which develop number sense and a visual understanding of number, where students can practice knowing number facts in a learning environment that is encouraging and fun. The slide above shows a game called Closest to 100, where students roll dice, find the product of the numbers showing on the dice, and construct an array, or rectangle, to represent that product. The goal of the game is to fill up the 100 grid as much as possible and can be played as a competitive or collaborative game. This activity provides an authentic way to practice number facts, where students self-monitor, peer monitor, and give feedback to one another. The game utilizes the learning power of the visual cortex, the part of the brain that processes visual information, to give students a solid understanding of multiplication, and helps construct a relational framework, connecting the concept of multiplication to the concept of area. In other words, we know that seeing, or visualization, deepens understanding. Beyond basics, what about numeracy? Alberta education defines numeracy as the ability, confidence, and willingness to engage with quantitative or spatial information to make informed decisions in all aspects of daily living. The slide presents a question which many of us see in our day-to-day lives. What computational strategies would we as adults use? Is this mental math for some but not for others? Would mental math involve an algorithm or maybe a visualization? Here is one way to represent and visualize the product of 12 times 13, using an area model. In an activity called a number talk, students would develop and discuss different approaches to finding the product of 12 times 13. How would you solve it? You may start with multiplying 12 by 10 and then add 26, or you may know 12 squared and then add another 12. In our experience, students are often excited to see and discuss the creative ways other students are solving the same problem. This helps some students redefine their understanding of math as a creative sense-making experience rather than a collection of memorized facts and rules. Teachers and students use manipulatives such as base 10 blocks to employ the learning power of visualization. A digital version of base 10 blocks is shown on the slide. This area model helps grade 5 students visualize the product, connect their understanding of place value, and develop strategies for computation beyond the standard algorithm. The concrete model using base 10 blocks is extended to an area model. The idea is further abstracted in grades 8 and 9, where students are introduced to perfect squares, square roots, and the use of exponents. By grade 10, students substitute variables for constants and can use the same model to find the product of binomials or factors of a trinomial as shown in the model on the right. Knowing the basics is important. However, math is more than computation and formulas. Alberta's math program inspires students to apply reason and logic to creatively solve problems, providing a foundation for an engaged mathematically literate citizen. Here is a video from one of our high schools showing how problem solving is embedded in instruction to deepen student understanding of topics.
Problem solving is mathematics. If you're just learning technical skills, you're just learning arithmetic. Those are important, absolutely critical steps towards being able to solve a problem. But that's the whole point of math, is to be able to approach situations that are new or different, or maybe a little bit more complicated than what you're used to, and to apply the things that you've previously learned.
In CNF, it has to be this function. There's no other functions. But if you do a y and an x, it will be like this, and then your inverse will be the opposite of that, which is something like
if it's
that.
symmetrical.
So it's a different function if you inverse it. But if you have C and F, which are known variables, then that's the only function there is. You cannot say that the inverse of it is another valid relation, because this is the only relation that works. So you're not, in fact, changing
pretty much
the
just
variable.
domain
Yeah, simply, no, not domain. You're not changing the variables. You're only isolating one variable and then changing this, and then using the same relation to isolate the other variable.
Sort of what I was after here with this assignment is, okay, you know this thing about inverse functions that is in a vacuum. What does that look like when you actually try and embed it in a context, and how does that force you to add nuance to your understanding of what's going on?
Historically, the mathematics that was learned in school was dominated by isolated facts, skills, rules, and procedures to be memorized and practiced. It has been reported that the mathematics curriculum is shallow, undemanding, and covers too many topics superficially. Many adults also believe that only a few gifted people can learn mathematics. However, we know more today about how people learn, and it has changed this old view. The mathematics processes shown on the left-hand side and the nature of mathematics on the right influence the learning outcomes in all mathematics programs of study. The 7 interrelated mathematical processes are critical aspects of learning, doing, and understanding math. From kindergarten to grade 12, students encounter these processes regularly through their learning journey in math. Change and constancy are 2 aspects of the nature of math which helps students appreciate and develop a deeper understanding of math. As we watched in the earlier video, the result of 3/4 and 1/2 change depending on the context of the problem, such as the size of the ice cream pail. Constancy in the nature of mathematics helps students solve problems, as they have explored mathematical properties that remain constant. For example, as a numerical property, 3/4 is greater than 1/2. In part 2 of the grade 5-6 classroom video, you will see a math lesson that has been designed for students to think deeply about mathematics and problem solving. Through this learning task, students are developing and demonstrating the mathematical processes in the areas of communication, connections, reasoning, problem solving, and visualization.
Our whole is now 1 yellow hexagon and 1 blue rhombus. That's the whole. What you think the value of 1 rhombus will be now, what the value of 1 triangle will be now, what the value of 1 trapezoid will be now.
1 trapezoid. Wait, I should probably trace this first.
You can talk while you trace, if you're able to do that.
And transformed into triangles, that would be 8 of them. So, since we have that many rhombuses, maybe that could be the value of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we have 4 rhombuses.
But
So
how
would that work? 11. Well, I'm thinking it might work because of that being worth 2 triangles. And we could break it into the smallest shape possible.
So one of these would be
Yeah.
Oh, I get it.
And so then the hexagon represents 2 out of 11. No, the rhombus is 2 out of 11. And then the trapezoid is 3 out of 11.
It's very important to learn through problem solving. That is essentially the essence of developing solid mathematical thinking, mathematical learners, students that can communicate their mathematical thinking effectively.
The mathematical discourse shown in the video, where students describe and evaluate solutions to tasks, share approaches, and make conjectures, keeps the cognitive demand high for all learners and creates a powerful and authentic learning experience. In the final part of the video, the student was able to effectively communicate his understanding of comparing, ordering, and finding equivalent fractions, both verbally and in written form. Student learning is assessed in relation to the learning outcomes on the report card. As we have shared with you before, the report card stems are a synthesis of the entire program of studies. This visual represents the connection between the 5 report card stems from grades 1 to 9 and the 3 dimensions of mathematical understanding that we introduced at the beginning of the presentation: problem solving, conceptual understanding, procedure of fluency. Our goal is to promote and foster understanding of mathematics for all learners, where students are doing, thinking, and talking math. Teachers, as designers of learning, are assessing students and maintaining a balance of the 3 dimensions of mathematical understanding. Alberta's math program encourages students to develop mathematical reasoning and problem-solving skills and make connections between mathematics and its applications. Our program also builds students' confidence in their mathematical skills and appreciation of the subject. Alberta's math programs require that students can not only add, subtract, multiply, and divide, but they also know how to reason and solve problems in real-life situations.